Hello, friends. Well wishes. In continuing the chapter of motion in one dimension, today we shall learn something about graphs. You have already studied about graphs in the previous classes. Graph is what? Graph is something in which we draw x-axis, y-axis, and then we plot different points. Okay. So before we start with the graphs, let us take at two important things. Number one is the uniform motion. Okay. Uh, if I ask you the definition of uniform motion, it is simple that if a body covers equal distances in equal time intervals, then the body is in uniform motion. Okay, very simple. But what is the meaning of uniform motion? What is the meaning of this sentence? Many times this will happen that definition is written in a different manner, and the mathematical meaning, if you want to take out the mathematical meaning of the definition, you will have to describe in a different manner. So this is how we describe uniform motion. There is no change in speed and there is no change in the direction of motion. In other words, acceleration of the body will be equal to 0. So whatever equations of motion we have learned, the 5 equations of motion, in those 5 equations of motion there is only one equation in which acceleration does not occur, or in which acceleration is 0, and that equation is this very simple equation: speed is equals to distance upon time. Okay, so this is the only equation that is applicable for uniform motion. All the other equations are applicable for exclusively non-uniform motion. Now let us come to what is non-uniform motion. Okay, see this. According to definition, what is non-uniform motion? If a body covers unequal distances in equal interval of time, the motion is non-uniform. If the body covers equal distances but in unequal interval of time, the motion is again non-uniform. Okay, but what does it mathematically mean? See, physically, in physics, it means that if a body is doing non-uniform motion, there is a change in its speed, there may be a change in its direction, or maybe there is a change in both speed as well as in direction. So if any of these things occurs, the motion becomes non-uniform motion. And the mathematical meaning of it: acceleration of the body is not equal to 0. It can be a positive number, it can be a negative number. See, if acceleration is positive, or means if a is greater than 0, then the speed is increasing. That means it is accelerated motion. And if a is less than 0, what it would mean? It would mean that, yes, the object is retarding, the object is decreasing its speed. And which equations are used in non-uniform motion? All the equations having the term of a, v is equals to u plus at, s is equals to ut plus half at square, all the equations of motion are used for non-uniform motion. So this is the difference between uniform motion and non-uniform motion. Now, before beginning the numerical part of this chapter, we will have to learn a few more things about graphs. Today I am speaking a little fast. If you can manage with this speed, please let me know, and if you cannot manage, then also let me know. Okay, so the next topic which we have to learn is the topic of graphs. You have already learned the topic of graphs. Now let us review those topics which you have previously learned, and let us learn something new also. So let's learn graphs. We first write a very simple equation, very simple equation: x is equals to y. And to plot the graph of x equals to y, first of all we have to draw a table. The table in which we place various values of y, 1, 2, 3, 4, and because the equation is x is equals to y, the values of x will also be 1, 2, 3, 4, and when you plot it on a graph paper, it will look somewhat like this. What somewhat? It will look exactly like this. This is the graph of the equation x is equals to y. Okay, very simple one. Now let us go for the next equation, x is equals to minus y. So this is the equation x equals to minus y. Okay, first we do what we do, we take the various values of say x, and we write it as say 1 2 3 4 5. And what is the value of y? Value of y will be minus 1 minus 2 minus 3 minus 4 and minus 5. Okay, here you can just say that I have taken the values of y as minus 1 minus 2 minus 3, and the values of x will be 1 2 3. When you put the values of y in this equation, you will get the values of x. And when you take a graph paper and when you plot this points 1 minus 1 2 minus 2 3 minus 3, the graph will look like this. The graph will be in the which quadrant? The graph will be in the fourth quadrant. So now try to differentiate this first one. This is the graph of x equals to y, and this is the graph of x equals to minus y. Now compare both these graphs, compare both these equations. Let us move further. Now this is the equation x equals to 2y. X equals to 2y. Okay. So the equation x equals to 2y. Take the values of y as 1 2 3 4. Then the values of x will be just double than that, 2 4 6 8. Okay. You draw this table, and after drawing that table, plot this on a graph paper. The graph will be like this. Okay. Now compare again this graph with the previous graph of x equals to y. Can you see the difference? This is the graph, the green one. This is of x equals to y, and this graph is x equals to 2y. Okay, what happens to the line in the graph? Previously, the line was exactly bisecting the 90-degree angle, and in this graph, the line is little inclined towards x-axis. The line has moved a little towards the x-axis. Now let us go for one more equation. X equals to 4y. X equals to 4y. Again we do the same thing. Put the values of take the values of y 1 2 3, and then find the values of x, that is 4 times the value of y. 4 1s are 4, 4 2s are 8, 4 3s are 12. And again we plot these points on a graph paper. You can see that blue line. What has happened? Okay, the graph has now moved again a bit closer towards x-axis. You can see this graph is of x equals to 2y. The line has moved a little towards x. Here the line has moved a little more towards x. Now can you guess, if I draw the equation x equals to 6y, what will happen to this line? Will this line be more towards x-axis, or it will be closer to y-axis? Obviously you understand it, correct? If you say that the line will move a little closer to x-axis. Okay. Now all these three graphs and all these three equations, x equals to y, x equals to minus y, x equals to 2y, and x equals to 4y. All these graphs, you can see they are straight lines, and you can also see that these equations which I have written, they are all what kind of equations? They are linear equations. Why they are called linear equations? Because when you draw the graph of these lines, what you will get? You will get straight lines. That is why they are known as linear equations. Now let us take a look at non-linear equations, exponential equations, and this is a non-linear equation, x equals to y square. Okay, x equals to y square is the equation. First we draw the table from this equation, take the values of y, plotting the equations x equals to y square, take the values of y as 1 2 3 and so on. The x will be squares of that will be 1 4 9 and so on. And now if we plot these points 1 1 4 2 9 3, the graph will appear like this. This is how the graph will appear. If you see the graph in the first quadrant, it is not a linear graph. Okay, so the graph in the first quadrant is obtained by these values. Now you will say, how can we draw the graphs in fourth quadrant? Well, if you take the values of y as -1, -2, -3, -4 onwards, then you will get the below line which is in the fourth quadrant. Okay, so this is an exponential equation, their table, and this is how the graph looks like. The changed equation, y is equals to x square. Previously it was x equals to y square and the graph was like this. Now it is y is equals to x square. We take both the positive as well as the negative values of x. So if x is 1, y is 1, x is 2, y is 4, x is 3, y is 9. Now take the negative values of x. If x is -1, y is 1. If x is -2, y is 4. If x is -3, y is 9. If x is -4, y is again 16. So whether you take positive values of x or negative values of x, you are going to get the same values of y. And now when you plot this graph, you will get this. Okay, if you see the red colored portion of the graph, it is obtained on plotting the positive values of x. And if that green line you see, that is you will get if you take the negative values of x. So this is how the graphs will actually look like for x equals to y square and y is equals to x square. Now what I want from you today is that I have drawn these 5-6 equations and their tables and their graphs. You also confirm that are the graphs really like this? If your answers are similar to this, let me know. If your answers are different than this, then again let me know. But you have to try it on the graph paper yourself so that your concepts become very clear. Okay? Try it in the rough. Okay, there is no need to copy down the fair copies, but you must be confirmed that how the graphs are actually looking like. Now we study one more aspect of the graph, and that is slope of the graph. What does slope of graph indicate? It indicates that how much inclined the graph is. Okay, say there are 3 lines in this graph of x versus y, graph number 1, 2 and 3. Clear? Now see, line number 1. The line number 1 is having lesser slope, line number 2 is having more slope, and line number 3 is having maximum slope. Okay, actually the slope of a line will tell you that what is the verticity of the graph, that how much the graph is having vertical nature. Clear? Now if you understood what slope is, okay, if you understood what slope is, what is the concept of slope, then we now calculate the slope. How to calculate the slope of a graph? See, I have taken 2 lines, one in the first quadrant and one in the fourth quadrant. You can take a look at the coordinates. x1, y1, x2, y2 are any 2 points on the upper graph line, and the below graph line it will be x3 minus y3, x4 minus y4. Now the y numbers in these coordinates in the below graph, they are negative. Why? Because in the fourth quadrant the values of y become negative. Now how to calculate the slope of any graph? We have a simple formula for that. Slope of a graph is represented by the letter m, and it is calculated as the final y coordinate minus initial y coordinate divided by final x coordinate minus initial x coordinate. Okay, so this will exactly tell you that how much the graph is slopey. Clear? What you have to do? Subtract y coordinates, divide them by the subtraction of x coordinates. If the number is large, then you will get line number 3, and if that number m is small, you will get line number 1. Clear with that? Now Coming to the linear equation, this is the linear equation. This is how we write any linear equation. You know what is linear equation? Yes, the linear equation is the one whose graph is a straight line. So this is a general linear equation. Y is equals to mx plus c. Y coordinate is y, x coordinate is x, m represents the slope, and c is any constant number. Okay, for the time being we omit that c, it's a constant number. Okay, how to calculate the graph? You can see y is equals to mx if we neglect that constant. So what is m equals to? M equals to y by x, or m equals to delta y by delta x. So this is how you calculate the slope of any graph. And now finally coming to the area of a graph. Very easy one, very easy. This is very much similar to how we have been calculating the areas of different surfaces, rectangular surface. You know how to calculate the area of a circle, square, rectangle, trapezium, etc. So in the same way we are going to calculate the area of graph. Say any typical graph we take, this one. How do we calculate this area of this graph? Very simple. Area, any area is equals to length into width. So the area of this graph is taken as y multiplied by x, y coordinate multiplied by x coordinate. If it is a trapezium, then you have to use the formula how to calculate the area of trapezium. Okay, if the graph is having circular nature, you have to use to find the area of circle. You know what it is? Pi r square. So this is how we calculate the areas of graphs. That is all for today. Thank you so very much.